Okay, let's start. Good afternoon. I'm really glad to see all of you here on Yerevan testing days. And also I'm excited for the opportunity to share my experience, some ideas with you. So shortly about myself. So I started as a R&D engineer and then moved to software testing, member of Armenian board of ISTQB, also currently manager of quality engineering at Synopsys. So, but the most important achievement in my life, I think, I have 3 kids, and I like to build with them, do robotics, building with them robots, and we represented Armenia on a couple of international competition. We have good results, but still there are areas to improve. By the way, it's some little bit connected with my today's topic, with the performance. And after my talk, if you ask me a question, I will answer to the question how it's connected. So now about the story. So when I was thinking about the topic, the subject, which I would like to share with you, I decided myself to share with you the most challenging part currently I'm working on, and decided to pick up this subject. So we have an enterprise client-server solution, and performance is a very critical quality characteristic of our application, and it's very important to have a better performance than competitors has. Now, during this presentation, I will share my experience, challenges which we are facing, and possible solutions. Why possible? Because for some areas, there is no exact solution right now, but I have some ideas which maybe some of you can continue working on this direction and maybe achieve some real solutions or real results. So what we do with the performance testing, first of all, we are following a regular test process, like starting from planning, doing design, implementation, and finally reporting the results. And based on these results, usually what happens, development team are fixing issues or just saying that there is not enough time because release tomorrow, we are taking this kind of risks and going to production. So what next? Actually, when we do this process properly, next step is we are choosing some subset of our tests and putting in regression to just have a control over the versions. For next version, we exactly know what kind of changes we have in our application regarding performance. So improvements, degradations, etc. Then, once we have a solid enough regression, we can rely on this regression to judge all the changes, to track all the changes, and putting all these regressions, as usually happens, for maintenance. So one important part here, just to be clear, and what we measure, because for performance, there are a couple of critical and important parts which are not usually applicable for other types of tests, it's measurements. So measurements are crucial here. And what we measure basically 6 main indicators, service-oriented indicators like response time, availability, concurrency, and also efficiency-oriented indicators like utilization, throughput, scalability. During my talk, I will not dive deep in this kind of measurements and how we are doing this measurement, because I think you all know that for this kind of performance measurements we are using tools, different tools, but this is not about my topic. So now, as a couple of times I heard during this conference, we are doing not best practice, but we are doing some good practices which are actually work good for us. So let's imagine during the entire test process, we collect a lot of information about tests and test results. And I'm talking about particularly for example, functional test, integration, and system level tests. All these test results for us collected in a single database with all metrics. So what we are doing, we are using this information and analyzing those and having more wide picture for what kind of performance changes we have from version to version. This is, I think, a very good approach, because if you have this kind of information in your system on a database, this is very cheap. I mean, without any significant investment, you can get more results on a performance test. So next good practice I would like to share with you is related to single vector at a time approach. Let me a little bit explain what I mean by single vector. We can imagine that each indicator is a function of different factors affecting on a performance. These factors are very, very many because, for example, environment can affect performance, operating system type can affect performance, data type, data mount, right? Configurations, everything affects performance. And when you test performance, right, you don't know whether it's good or not, whether it indicates a problem or not. To focus on a single area and exactly know where the problems are, you can have this approach, single vector approach. What does it mean? Let's say, for example, we have a function which has let's say 5 properties, right? 4 properties, and one of them is test environment, second configuration, whatever user selected on UI, and data, right? So by saying a single vector at a time, I mean we need to make a constant 3 of them and just change one of them at a time. This works very good for us because we have a lot of configurations, a lot of variations of data, and very difficult to judge whether it's a performance problem comes from this configuration type or data type, or the problem is I don't know, operating system or database, it's very difficult to judge. But with this approach, we could eliminate exact problems. And because you know what happens usually, especially for performance problems, when we are reporting problem, it goes to developer says, we cannot reproduce, we cannot understand with this description, right? That is why it's important to report the performance issues, performance bugs, very, very detailed, and provide as much as possible information. Otherwise, these bugs never get resolved. So with this approach, this is an example. We can fix, here we can have, we have different vectors, right? And different data sets. If you fix a vector, right, and change just a data set and see a problem here, because it's a problem of linearity on a vector tree. Another good practice we are applying is regarding breaking points. So what happens for us, especially for some vectors, we don't know exactly when we are expecting breaking point or not, because it's not clear defined for some cases in the requirements. That is why what we do, actually this chart is some kind of continuation of previous one. Just what we do, we continue growing load until break the system. So once we have a breaking point, we can apply here boundary test approach. What we do, just we keep these 2 points, the breaking points and last succeeded points, and putting these 2 cases into our regression test for stress test. What we gain here, actually we gain here a lot of valuable information which we can provide to our stakeholders to share with the development team or other teams, that we know exactly when the system has been broken. And going forward with new releases, new versions, we know we are able to track all the changes on the breaking points. Okay. Let's imagine we do performance tests very well. But for most of cases, especially for it's too late. Because usually performance test happens on the last minute. So because performance tests we are doing on a whole system, when the entire system is already ready to go or ready to run at least. And when we find some critical issues, right? For many, many cases, it's impossible to just fix within a couple of days. If we look at the real problems, real defects causing the failure on a performance, these are design mostly problems. Also computing problems, I mean how fast your algorithms are working, and especially design problems, very expensive to fix. And I'm not only talking about the dollars, right? I'm talking about time. They are expensive to fix from a resource point of view. So that is why it's too late, still too late. So, of course, performance test is good because we don't want to firefight, but it's still carries a lot of risks. So if you, let's say, did all performance tests very well, still there are a lot of risks there. So I'm moving to main part of my presentation. So what can we do to improve the situation? So first of all, this is actually all the main stages of development process. These requirements, design, coding, testing, and production finally. So we know that performance testing and maintenance are here, testing and production. So what we miss, it's clearly shown here that we are missing 3 steps. You can argue me that we are doing a review, for example, for requirements, yeah, but I don't think it's enough. So how to cover these 2 steps? Design and coding. So here, some ideas. So first of all, let's start with reviews. Yeah, reviews still are most good practice to prevent defects. We need to be careful and invest in reviews. So, for example, me, I'm investing with my team a lot on reviews. So, and for sure, we see results because, you know, reviews are most important part of the entire fundamental test process. So, starting from marketing requirement documentation, what can we do? First of all, we need to determine expectations and also build performance goals. I don't mean the test engineer should do that, but we should make sure all this information are there. Actually, the main source for this information comes from marketing, from competitors, and just comparing the last version with new version, or I could say benchmarking between versions. This is very important to have a so-called performance-oriented review process in your organization. Next type of documentation, also very important, is a test plan. Test plan should be part of master test plan and should be aligned with the project plan. Because performance test starts very early when you need to identify your scope, your goals, and define the sources you need to allocate, and also build an environment, start working on tools. All this stuff should be done as early as possible. Low-level specification, like functional specifications. So on this level, we should already start thinking about more detailed expectation from performance point of view. Okay, so we talked about the reviews, which are, I think, covering the requirements, because requirements just documentation. Nothing else we can do with the requirements. We can just review and find the defects within documentation. So next is a design. When your application designers are working on design, I think what can we do? So this is, by the way, idea which I want to share with you. There are some pieces of this solution, but you need to find which works best for you. First of all, you need to build in parallel with the design model are built for the entire application, you need to build performance model of your application, putting all necessary information as a property to this model. But by the way, for performance model building, creation, there are a couple of approaches, like a scenario-based, object of component-based, but it doesn't matter. So if you have a model-based some kind of process within your organization, I think it is very possible to build a performance model based on existing models. So next is a representation of the model. There are a lot of types of representation. One of them is a unified model language. So you can represent your model, then based on this model, so-called execute it and see the performance bottlenecks, defects in a design in the early stages. So we talked about requirements, design, now about coding. So for coding, there are a lot of good practices how to build your code efficiently. So what does it mean? First, I categorize these points in three. First category is maximum usage of the compiler or processor, means the following. So compiler has a lot of options to compile, and also compilation specifics, right? You can compile your code on some particular specific hardware. You can compile as something which can be portable from hardware to hardware. These are a lot of options here, but these are affecting on a performance definitely. Next is bit hacking. So what does it mean? It means that bit operations actually very cheap to compare with the ordinary math operations. If you have a chance as a developer to use these bit hackings, you can gain a lot of performance here. Logical operations is a kind of part of it because bit operations hackings are very related to logical operations. So nowadays, CPUs are using branch prediction. Do you know what is it? Branch prediction. Yeah. So with your coding style, if you can help CPU to predict branch better, then again you will gain a lot of performance. And next one is high performance libraries. When you are, I can imagine, so my friends or my colleagues are, when they need some library, just Googling and taking this library without caring about the performance for sure. But there are libraries, third-party libraries, which are specially built for performance. So this is also one of small thing can affect on the performance. Next category is choosing right algorithms and data structure. I think nothing to say here about algorithms because you understand, right? Right algorithm should be in place, definitely. But choosing algorithm, developers are facing to problem, not a problem, just a usual thing to choose right balance between space and time. What does it mean, space and time? Space means more allocating memory. Time means more using CPU. So you can, I can give an example. Let's say you have a loop and you are calculating something, right, over and over. This is time. When you have a loop, the same calculations, but you are just keeping some additional information within this loop. In a memory, you are gaining time because you don't need to go through these millions of loops. Instead, you can just 100 times do the loop. But you understand, right, the balance between using allocating memory and using the CPU as a resource. And this is, by the way, not easy to do, but this is also a very important point to gain more performance. And finally, about loops themselves and procedure rules. First of all, the most important part here, loops. Why? So because statistics says that 90% of time goes through execution of 10% of code. So that means you can keep your focus on this 10% of code. What usually happens is happens in a loop or inner loop, right, which computes millions of time. And if you keep focus on this particular loop, you can optimize it as much as possible, and finally you will have a better performance for sure. So there are, by the way, some articles on the web regarding these rules, known as the Bentley's rules. Okay, so we had just testing and production, right? Now I try to cover all these three ahead of testing. For requirements reviews, for design model-based prediction approach, and for coding code optimization. These are very important steps. If you have all these steps in your organization, I'm sure you will reduce performance risks very much. Now next question is, how can we apply in our processes, right, in our organization? If you have in your organization review process, like an inspection, I think just what you need to do, just add performance-oriented review methods and try to discover and find performance issues in a requirements documentation. For model-based prediction, if you have in your organization model-based approach, there are different approaches regarding model-based. There is a model-based testing approach. There is a model-based development approach. If you have this kind of practices in your organization, that means your team are able to create models based on the, let's say, requirements or other design documents, and based on these models, create performance model and try to predict performance issues. So for code optimization, just if in your organization it's practical to have a coding best practices, guidelines then just you need to add this code optimization part in your process. So I almost completed my presentation. So just my opinion, I really believe that if you or we can invest in these areas and cover this part, then you will have a better performance for your application, for your product. So, actually, questions? Yeah, sure.
Why coding and testing are not in parallel in your... when I was working in Synopsys, we have a performance validation tests, which are running weekly, and we find out performance issues from the each check. And I think coding and testing have to be in parallel.
Yeah, good question. You are right. They could be intermingled. But when I'm talking about coding here, so that means before checking. So you need to think about how to optimize your code before checking in. Because when you already checked in the code, that means the code is ready for test, right? That is why it's separated. Yeah, by the way, good point, because as I understand, you are talking about even component level testing, right? So this is also good practice to start performance test as early as possible. This is one point when you can even do performance tests on your modules, right, on your components, before having entire picture, I mean entire application ready for run. Thank you. So question? Yeah, sure.
When we are talking about CPU and memory,
yes.
As far as I know, CPU is very cheap when we're comparing with memory. Are we taking account that comparison CPU and memory? I think they have not to be in the same level, their usage. CPU, because if I will be customer and you will come to me and I will give you money, you can both more CPU and little memory. And I will see there that CPU can be more than memory.
No. There was a point, right? So I can show you if you would like. Yeah, space to time to space for space. So that means you need to find the right balance between those. I mean CPU and memory. And I mentioned that this is a difficult job, by the way. And as a result of this kind of issues, you can have issues on utilization, by the way. And that means, let's say you are not keeping the right balance here, right? And memory grows, that means utilization will cause a problem, right?
If memory grows, I have to pay more money. If CPU grows, it doesn't matter for me because it's cheap.
But anyway, if we look at it as a resource, it's limited, right? Even CPU. So let me explain. So if you, let's say we grow memory, right? This is, as you said, expensive. But when we grow the CPU, it may cause a response time problem. Because when all the CPUs are busy, right? You have a big queue in your execution statements, right? Then it causes another problems for performance. So that is why it's right balance is very important here. Okay. Okay. Okay.
Yeah. What tools are you using for performance testing, especially in early stages of startup?
Thank you. Good question again. So the question is about tools, what kind of tools we are using, especially in early stages. So I'm working at Synopsys, and we are using our internal tools. So that is why it's some kind of specific of us, maybe.
Only.
Yes, mostly. So if you are talking about GMeter or no, we are not using. Okay, question? Yeah.
Sometimes in a customer side, environment is different from SPS. Do you offer any solution for to maintain performance?
Yeah. Again, good question. As I mentioned, the performance is one of the factors, right, affecting performance, and for especially performance, that is important to have an environment as close as possible to customer environment. Yeah, we are trying to replicate. Maybe the same amount of memory will not. So we'll not have the same amount of memory, but the configuration of servers we are trying to keep the same. And anyway, there is another approach. If for your organization it's applicable, you can use customer staging environments for that purpose. We have this kind of practice, so we are using customer staging environment. They are allowing to do the beta acceptance tests on their side.
So one question. You said at first of presentation, there are some areas where there is no some solutions to metrics. Could you provide some examples?
Yeah. Especially for me right now, I'm working on a model-based prediction, performance prediction part, and there is no exact solutions right now, as I know. Yeah, okay.
Artak, thank you for your presentation. And one question. If you talk about performance engineering process, very important part of this process is training for some results that we have after some changes and so on and so on. And sometimes I saw that there are could be a lot of products when you try to compare some results before, after adding of some new features and so on and so on. And from your experience, do you have some kind of best practices or something that give us ability to build the best approach that gives us good and effective training in future? Do you have something like that?
So control.
How to do your tests for getting ability to compare something easier? To do training without big problems.
Let me answer to question. I don't know whether I understand correctly. So first part is comparing two versions, right, of your product to find the performance changes, right, whether it's improvement or degradation. So what we are doing, we are for new features, for new versions, we are doing deep performance tests for these new features. Once we did it, we are selecting some important test cases, right, from this performance test suite and putting in regressions. we are not putting entire test suite because they are big and you know performance tests are taking a lot of time. This is for control, right? To see with new versions how we are doing well, right? With the performance. And for trends, I don't understand actually because how can I measure trends of performance?
Yeah, for example, you have a list of features. And
Yeah.
You know that these features days, for example, I don't know, response time in general is 1 minute. And you want to compare this execution time of each feature, for example, couple months ago and now. And in this case, I think you should use some tool. Sometimes I saw like it's possible to do it in Excel and so on for doing this comparison. For example, to compare one transaction with another transaction, and sometimes there could be a lot of problems.
Understand.
What we do in this case? Maybe a specific tool or specific approach or specific approach for building your test.
Yeah, okay, cool. So now the answer. As you remember in my slide, I showed the database, right, part. You remember. We are keeping all our results in a database. That means with the metrics, with the environment, right, all the other attributes are affecting performance are kept in database. So what we are doing, we are just analyzing these results. You understand a lot of information are there. So analyzing is much, much cheaper if you have already this information. So by the way, am I asking your question, answer to your question? So we are just analyzing all the data and we see the trends, modifications. By the way, one good example, one small, not so small, actually we noticed about a performance problem on some particular function within our huge application. And by the way, the root cause was moving from one version of library to another, third-party library. So this is an example of that.
Last one question. From your experience, what do you think, for example, in my project, mostly for our metrics, we use 90% deal, or sometimes 95% deal. And, but there could be different situations. What do you prefer from your experience? What percentile do you use? Or you don't care about such approach, you use something else, you use, for example, 99% deal?
So you mean what kind of threshold we are using to judge whether it's a problem or not? So I didn't catch.
The percentile is like an approach when you draw some values that are out of some kind of, I don't know, like equivalent class and so on.
So we are.
I know just percentile term.
Yeah, eliminating spice, right?
Yes.
Yeah, we have this kind.
What percentage do you prefer? What is the best one?
So, okay, if you need a number, if I'm not mistaken, it's something like between 10 and 20.
Okay.
I mean difference.
Yeah.
Do you use Artak methodology in your work?
Which methodology, sorry?
Artak.
Updex? No. It's about performance again?
It's high level. We use it in higher level comparison. Task new field looks
Good.
better than Korea. So it's kind of you can get a good coefficient up to 1.0, and for example, previous build shown this coefficient 0.85, and new build shown 0.8. It says that rebuild is worse than previous, and we got problem, and we should we should figure out why. And if new build says that he got 0.9, that it says that it's all right.
Okay, so
And you can say that something went wrong.
yeah, but is this particular for performance?
Yeah.
Okay, maybe we can talk. İsmet? Yeah.
Performance test on UL diagrams. So it is something theoretical, or you are actually using some coding or tools to do it?
You know, yeah, it's some kind of theoretical now. But I read some articles about there are some tools. But you know, as I mentioned, that there are 3 steps here, right? Main steps. Just defining the model itself, representing it, and just trying to run it, right? So this part, for each part, as I know, there are tools, but it needs to some investigation how to integrate all these tools together and get some final picture or results. Okay, thank you.
I want to know where ending performance testing and where starting performance engineering. Where is the line?
So performance engineering umbrella covers the performance test itself, but performance testing, as I mentioned, has to do something right now on a requirements stage, then on a testing. Because also we can, of course, review the design documents, etc., but it required some special experience to understand from just diagrams or from models, right, or predicts performance issues. This is very difficult. Yeah. Thank you for question. Thank you.